Here's the truth nobody tells JavaScript developers about TypeScript: you already know 90% of it. TypeScript is JavaScript. Every line of JavaScript you've ever written is already valid TypeScript. So this video is not a from-scratch language course. It's the other 10%, the small set of things that are actually new. Type annotations, unions, interfaces, generics, narrowing, a config file, and how to migrate a real file you already have. Learn just this 10% and you can read, write, and ship TypeScript today. Every snippet is on screen, and it's all correct, copy-pasteable code. There's a free written guide in the description with every line. Let's get the 90% out of the way and go straight to what's new. The first new thing is a colon. That's really it. After a variable name, you add a colon and a type. A string. A number. A boolean. When something is a list, you write the element type followed by two square brackets, number, bracket, bracket, that's an array of numbers. And on a function, you type each parameter, then put the return type after the parameter list, again after a colon. But here's the part beginners overdo. You usually don't need to write these. TypeScript infers the type from the value. Write let x equals 5, and TypeScript already knows x is a number, forever. Try to assign a string to it later and it stops you. So the rule of thumb, let inference do the work for local variables. Add annotations where it actually helps, on function parameters, and at the edges of your code, where the type isn't obvious. Annotate the boundaries, not every line. Now the first thing that feels genuinely new, union types. In plain JavaScript a value can be a string or a number, and you just keep it in your head. In TypeScript you write that down, with a single pipe character between the types. ID, colon, string, pipe, number. That means ID can hold either, and only those two. Assign a boolean and it's an error before you ever run the code. There's a sharper version, literal types. Instead of any string, you can say the value must be one of a few exact strings. Type $r equals the string up, pipe, the string down. Now a $r can only ever be up or down. That's how you replace loose string flags with something the compiler checks. Think of it as an enum you get for free. And when you have a union, you narrow it. Inside an if, check typeof ID equals string, and inside that block TypeScript knows ID is a string, you get all the string methods, safely. This idea, narrowing, comes back again and again. Next, describing the shape of an object. You've got two tools, and new folks agonize over which, so here's the simple rule. An interface. Interface user, then the fields, name is a string, age is a number. Two little modifiers earn their keep here. A question mark after a field name makes it optional, age $number means a user might not have an age. And read only in front of a field means you can set it once, but never reassign it. The other tool is a type alias, the word type, a name, equals, and the same shape in braces. For a plain object, interface and type are almost interchangeable. So which? Rule of thumb, reach for an interface for object shapes, especially ones you might extend or a class might implement. Interfaces are open and composable. Reach for a type alias when you need a union, a tuple, or to name a primitive, things an interface simply can't express. Object you'll build on, interface. Union or combination, type. That covers 99% of real code. Functions get a few new powers, and they're all quality of life. Optional parameters, a question mark after the name, like be $number, means the caller can leave it out. Inside, that parameter is number or undefined, so you handle the missing case. Default parameters, this is plain JavaScript you already use, b:number equals 0. If it's omitted, it's 0, and TypeScript infers the type from the default. REST parameters, 3 dots, nums, number, bracket, collects any number of arguments into an array of numbers. For return types, when a function doesn't return anything, its type is void, lowercase void. You rarely write it, inference fills it in. And you can name a whole function signature as a type. Type fn equals open paren x number close paren, then an arrow, then string. That's the type of any function taking a number and returning a string. Now you can pass functions around and have them checked, too. Quick, honest aside, then straight back to the code. If this 10% is clicking and you want to go deeper without the endless tutorial maze, I put together a TypeScript mastery pack. It's $19, the patterns, the generics, the real-world configs, and exercises that make it stick. It's completely optional, and the link is in the description. That's the whole pitch. Now let's talk about the feature that separates people who use TypeScript from people who really get it, generics. Generics look scary and they are genuinely simple. A generic is just a type as a parameter. Look at a function that returns the first item of an array. Without generics you'd have to pick an array of numbers, or strings, or something. With a generic you don't. Function first, then angle bracket t, angle bracket, that t is a type variable, a placeholder. The argument is arr:t bracket, an array of t, and it returns a t. Now call first with an array of numbers, and t becomes number, you get a number back. Call it with strings, and you get a string back. One function, fully type-safe for every type, with zero duplication. That capital T is a convention, you could name it anything. The same idea works on shapes. Interface box, angle bracket t, angle bracket, with one field, value, t. A box of number holds a number in value, a box of string holds a string. This is exactly how arrays, promises, and maps are typed under the hood. Once a type as a parameter clicks, the whole standard library stops looking like magic. Let's go deeper on narrowing, because it's where TypeScript feels less like paperwork and more like a helper. Narrowing is teaching the compiler what you already know inside a block. Use typeof for primitives, typeof x equals string. Use the in operator to check a property exists on an object, the string name, in, obj. Use array.isArray for arrays. Even a plain truthiness check, if value, narrows away null and undefined. In each branch, the type gets more specific automatically. Which brings us to two types people constantly confuse, any and unknown. Any switches type checking off. Give a value the type any and you can do anything to it, and TypeScript stops protecting you. It's an escape hatch you should almost never reach for. Unknown is the safe version. A value typed unknown could be anything, so TypeScript won't let you touch it until you prove what it is, with the exact narrowing we just covered. So when a value's type is genuinely uncertain, data from an API, a parsed blob, reach for unknown, not any. Any opts out of checking. Unknown forces you to check first. That single habit prevents a whole category of runtime crashes. None of this runs without one file, tsconfig.json. It's the settings for the compiler, and there are only a handful that matter on day one. The big one, strict, set to true. Turn this on from your very first line and never look back. Strict flips on a bundle of safety checks at once. The two you'll feel most are no implicit any, which stops values from silently becoming any, and strict null checks, which forces you to handle null and undefined instead of crashing on them. People who turn strict off later regret it. It's 10 times harder to add strict to a big loose codebase than to start with it. The rest are quick. Target, which version of JavaScript to compile down to, like ES 2020. Module, how imports and exports are emitted. Lib, which built-in type definitions you get, like the browser DOM. And ES module interop, set to true, so importing older CommonJS packages just works. Set strict to true, pick a modern target, and you've got a config that'll carry you a long way. Let's make this real. You have an actual JavaScript file, how do you move it to TypeScript? The answer is delightfully boring. Step 1, rename it. .js becomes .ts. That's it. Because your JavaScript is already valid TypeScript, most of the file just works. What changes is that the compiler now reads it and points at the weak spots. Step 2, fix what it surfaces, and it'll surface two classic things. Implicit any on function parameters, a parameter with no obvious type, so you add a small annotation. And possibly undefined values, a property that might not exist that you used as if it always does, so you add a guard, or a default. These were always bugs, TypeScript just made them visible. Work outside in. Annotate the boundaries first, function parameters, return types, the data coming in. The inside usually infers itself once the edges are typed. Don't chase perfection, get it compiling, then tighten. And if you're not ready to rename yet, there's a gateway. Put the comment // @tscheck at the very top of a plain.js file, and TypeScript will type check it in place, no rename required. It's the perfect toe in the water. Step back and look at the whole 10%, because that's genuinely all of it. Annotations, a colon and a type, but let inference do most of the work. Unions and literal types with the pipe. Interfaces and type aliases for object shapes, with optional and read-only. Functions with optional, default, and rest parameters. Generics, a type as a parameter. Narrowing with typeof, in, and is array, and unknown over any. A tsconfig with strict set to true. And migrating a real file by renaming it and fixing what shows up. That's it. That's the list. The other 90% was JavaScript you already knew. TypeScript didn't replace your language, it just wrote down what you already had in your head, and started checking it for you. That's the only 10% of TypeScript you didn't already know. You can read it, write it, and start migrating files today. Here's your next move. Turn strict on, rename one small JavaScript file to .ts, and fix whatever it flags. You'll learn more from that one file than from any tutorial. And if you want the deep version, advanced generics, real-world configs, and exercises that make it stick, the TypeScript Mastery Pack is $19, link below. The full written guide is free in the description. Subscribe if this made TypeScript click, and go rename that file. See you in the next one.